Here we are again. In today's lesson, we will talk about the resources that we get from the Earth's crust. We are going to review what is Earth's crust and the metal ores. We are going to talk about limestone and its cycle, fossil fuels, other forms of energy, among them hydrogen, and close with the land pollution. And also we are going to talk about the test for carbon dioxide. The Earth's crust is the top layer of solid rock of the planet. Goes 5 kilometers under some parts of the ocean and 50 kilometers under some parts of the landmass. And this is where the majority of the chemicals we use come from. 98.4% in volume of the Earth's crust consists of oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, 8 elements. And other elements make 1.6% of the volume of the Earth's crust. And it is in the Earth's crust where we get the ores from which we extract the metals. Ores are rocks which have a high concentration of a mineral containing certain metals. Most of the metals are reactive and they don't exist in nature like in the free form. They have impurities and they are connected or like in a compound with some other elements and they have impurities, and that's what it's form minerals. And these minerals are spread around in different rocks, and the rocks who have the highest concentration of these minerals are ores. As I said in the beginning, we get those ores, and these are the rocks that we use to extract the metal or the minerals, the elements that we need. Now, limestone is used a lot, and we use limestone for a lot of stuff, so I would like us to mention a little bit about it today, and through the course of the year we are going to talk more about different aspects of it, but just a presentation of the limestone today. It's a sedimentary rock, and the chemical is calcium carbonate and is in a form the mineral calcite. So the chemical name for the limestone is calcium carbonate, and is used in buildings, roads, to make glass, paper, cement, mortar, concrete, steel, neutralize acidic soil, is used in the furnaces to clean out the impurities. It is used to make lime and slake lime. And now we're going to go through the limestone cycle and see how lime and slake lime is made from the limestone. Limestone is calcium carbonate, so it's a carbonate. And the carbonates, when we heat them, carbon dioxide is released. And that's what happens with calcium carbonate. When we heat it strongly, decomposition happens, and we have the forming of calcium oxide, and calcium carbonate is released. The names for calcium carbonate are calcium oxide or lime and quicklime. We have to learn all these names because they are used throughout the syllabus. Calcium oxide or lime or quicklime reacts with water to form calcium hydroxide, which is a base, and is called slaked lime. Slaked lime is used by farmers to reduce the acidity of their soil. They spread it in the soil to lower the acidity. And acidity is when the pH is under 7, is less than 7. And you know the test for acidity. With a blue litmus paper turns in pink. And for the alkaline is the pink litmus paper turns blue. So we were here at the slaked lime. Slaked lime or calcium hydroxide, when we add more water, diluted solution of it is formed, and this is called lime water. It's still calcium hydroxide, the same compound, but is a solution. And lime water is used to test for carbon dioxide. Lime water is clear, and when we add carbon dioxide, this solution turns in a milky white because of the limestone that is formed. And limestone is a white solid, calcium carbonate. And as I said earlier, limestone is used in buildings and in making of a lot of stuff. Now here I have the word equations and chemical equations for what I said earlier. And I've used the names. You can pause the slide and learn them. But limestone heated gives lime or quicklime on carbon dioxide. And lime plus water gives slake lime. And when we add water to slake lime, lime water is formed, and lime water with carbon dioxide gives limestone. Now here I have the word equations and the chemical equations. I'd like you to learn this for these three reactions. For the first one, second, and this last one here, lime water and carbon dioxide. And as I mentioned, the test for the presence of carbon dioxide is that in the presence of carbon dioxide, clear lime waters turn into milky white, which is limestone. Milky white. We talked about fossil fuels and mentioned them when we talked about air pollution, and now we're gonna stop and see what we use them for. There are three materials, three things that make the fossil fuels. Three fossil fuels: coal, petroleum, and natural gas. And they are sources of energy. Over 80% of energy we use comes from these three sources. Coal covers like 26.6%, petroleum 36.8%, and natural gas 22.9%. And we use them as a source of raw materials to make plastic, detergents, drugs, nylons, cosmetics. And if it was used just for that, as a sources of raw materials would be okay, but because we use them as a source of energy, they're running out. They are non-renewable resource, and in your lifetime, we might run out of them. Main component of natural gas is methane. And before I go on, I want to talk a little bit why we use the fossil fuels as a source of energy. When the hydrocarbons burn, they release carbon dioxide and water and a lot of energy. The reaction is exothermic. Whatever the hydrocarbon is, when they react with oxygen, when they burn, they release carbon dioxide and water. And the process is exothermic. Even in the respiration, glucose, when it reacts with oxygen, releases carbon dioxide and water and a lot of energy that our body uses. The reverse reaction of respiration, we said it is photosynthesis, where in the chloroplast, the carbon dioxide from the air and the water that comes from the roots of the plant, in the presence of sunlight, they make glucose and oxygen. This sunlight is important because for this reaction to happen, it needs energy, and solar energy is the energy from the sun is the one that provides this energy. This reaction is called endothermic. Respiration is exothermic. Photosynthesis is endothermic. So remember, every hydrocarbon, when they burn, they release carbon dioxide and water, and the process is exothermic. That's why we use them as a source of energy. And when incomplete combustion happens, carbon monoxide is released. And there are other forms of energy that provide us the energy we need, and 6.3% of the energy we need is provided from hydroelectric power, and is nuclear energy 6%, and solar, wind, and wave power 1.4%. This something wrong with this picture. These are the renewable sources, and these are the one that we haven't tapped at almost. Sun is the greatest provider of energy to Earth. Solar energy on 1 kilometer square of desert is equivalent to the amount obtained from 300,000 tons of coal or 1.5 million barrels of oil. So there is an enormous energy in the sun, and this is the future. And hydrogen is one possible fuel for the future. And let's talk a little bit about hydrogen as a fuel and fuel cells. As I said, hydrogen is one possible fuel for the future. It is used to burn or is used in the fuel cells. When it burns, produces more energy per gram than any other fuel and produces water. That's a reaction. Hydrogen plus oxygen yields water. So pollution is zero, and the energy it produces is really high, is highly exothermic. But why don't we use the hydrogen as a fuel? Because of the low density, the transportation and storing is really difficult, and it's very expensive to provide hydrogen. Hydrogen is used for burning. It is used for burning, or fuel cell is provided from the electrolysis of water. And to separate water in hydrogen and oxygen requires a lot of energy. And this sometimes nuclear energy is used for this electrolysis, but even nuclear has its own problems because it's non-renewable, and plus the waste it provides is like will destroy the earth. So it's really expensive to provide hydrogen. But imagine if we can combine solar energy with a hydrogen, because using solar, if you use solar to split the water and get the hydrogen, use the hydrogen, be able to use hydrogen to burn in a fossil fuel, is going to be an amazing thing. But as I said, there is some problems there. And there's been attempts, Japanese burned hydrogen in the cars, and there was a study and a research done from Germans and British and Swiss when they used the fuel cells. What is a fuel cell though? Fuel cell changes chemical energy into electrical. So the chemical energy that is released from this burning of hydrogen, because it's exothermic, is changed into electrical in the engine and is used to run the cars. And that was experimented with Mercedes, the Benz. Now we talked about all these resources we get from the land, and we live in this earth, and all our activities is normal, will pollute the land. And some of the problems with pollution are littering, is domestic waste, and toxic and radioactive waste. Toxic and radioactive waste is really dangerous, and people bear radioactive and toxic waste, but that doesn't solve the problem, because it would get in the water supply and is really harmful. But there is a solution to these problems. The only thing that is required is will and means of doing it. A solution is recycling. Recycling not just lowers the litter, but we can reuse some of the materials that are non-renewable, like we can use aluminum, we can use plastic that is made from the fossil fuels, from the petroleum. So we can reusing them. There is two folds: keeping clean and saving something. And another solution is treatment of waste by burning to create energy. If we let the landfills, methane is going to be released during the decomposition, and methane is a gas that creates problems with greenhouse effect, with the global warming. But if we treat this waste by burning, we can create energy, and the gas released, carbon dioxide, is less harmful than methane. And the solution for this toxic and radioactive waste is treating the waste products from companies, and there are laws that require companies to do that, but as we know, always there is breaking of the law also. Now, here we have some questions, and you stop the slide and go through the questions and talk and discuss with each other. And for the next time, for homework, you have quick check questions in page 20, and I would like you to look through the summary in page 20. There is some good stuff in those summaries, and like in a way organizes your brain for what you need to know. So look through those. And during class on Tuesday, the 13th, we are going to work on the exam style questions that start in the page 21. This is an open book, individual work, and it is going to be graded. So you can open the book, you can consult for the answers the book, because my goal is that you catch up and learn things that you might have missed during the chapter. But it is individual. I would like you not to talk to each other, just you and your book. And if you finish during the time in class, go on and read in the second chapter, the first lesson, different types and substances. If not, finish them in home and turn back on Thursday. Turn in on Thursday. And here I have written what I want you to solve, because you don't have knowledge to cover everything. This exam style question is designed to be used at the end of the school year, so there is material there that you don't have the knowledge now. So I went through this and just wrote down what you can answer now. So from the first problem, I want you to answer to the A, B, and D question. Or for instance, here, from the 10 problems, I want to answer the A. From the B, just I and I. And from the C, just I and I. So go through those and solve these problems, and have a great time working. And we didn't finish the first chapter. Have a blessed weekend. Bye.